Hey y'all, today I wanted to go over something that we were supposed to go over um, today in class, but because of the third snow day in a row, we can't necessarily do that. But today we're just going to kind of relax. We're going to practice dependent versus independent probability and finding that, as well as conditional probability, which is kind of the recap of lessons 2.2 and 2.3. So today is another day to just kind of catch up. I have a game and then I have one little IXL thing for you to do, but it's mostly a time for you to just catch up, ask questions, join Zoom if you have it. But this was the thing that I wanted to clarify from actually question 19 on this 2.3 homework. So sometimes questions are going to ask you, is the event, or it says probability of A and B is this, probability of A is this, B is this. Are these two independent or dependent? And how do we find them? Well, in stats, when we want to find stuff, we just go back to the definitions of independent versus dependent. And so the biggest definitions slash equations we have is if we have independent events, here's what we know. The probability of A and B, this is also the intersection. Remember, we use kind of like this little swirly thing, equals the probability of A times the probability of B. Because they're independent, they don't play off each other. They don't impact each other. It's like rolling a dice and choosing a letter of the alphabet. They have nothing to do with each other. They don't affect each other. So if we're testing something, we always test to see if they're independent. And then by default, if the independent test fails, then they're just dependent. What I mean is this: if it gives you probability of A and the probability of B, we're going to multiply these two probabilities together and see if the number that we got is the same as what they gave us for the probability of A and B. And if that's not a true statement, if those two are not the same, then we know by default it's dependent, because remember, for dependent events, it's not the probability of A times the probability of B. It has a little bit of a shift. It's the probability of A times the probability of B, given that A already occurred. So that given that A occurred is that conditional part, that dependent part. And so what does this look like on a real life example? Let's go over to 19 on the worksheet. And so I'm looking at the answer key here, but let's walk through what we should do. Probability of A is 0.70. Probability of B is 0.40. If the probability of A and B is 0.25, are they independent? So we're going to test. We're going to take the probability of A, which is 0.70, and we're going to multiply it by the probability of B. If the events are independent, 0.70 times 0.40 should give us 0.25. And what turns out is 0.70 times 0.40 is 0.28, which is not the same thing as 0.25. So these are not independent, meaning that the events are dependent, because event B is impacted or affected by the outcome of the probability of A. In other words, the probability of B would have changed given what already happened in event A. This is why like order matters, or we talk about replacing things like when we draw cards out of a deck. It matters if you replace the card that you just drew or if you didn't. And so when events are dependent of each other, I'm not replacing the cards that I just drew from the deck. I'm drawing a card, and if that card is an ace, well, then there's only 3 aces for me to grab if I'm trying to get another ace from the deck. So things like that where they're dependent. But anyways, you're going to test them, multiply B times A. If they are the same as A and B, they are independent. You have this little note right here. They should be equal. If they are not the same, then by default, they are dependent. I hope this clarified a little bit. Feel free to try as many attempts on the game. Let me know if you have any questions about anything that we have today. And I hope to see you all back at school tomorrow.